Well, hello, folks. So this is, uh, the Phet app that helps you make sense a little bit of vectors. So just so you would know what's involved here, well, this is the x and y coordinate system. This is the magnitude of a vector that you would build. This is the angle determined from the positive x, and it helps with the direction because recall from your reading that a vector consists of magnitude and direction. If you don't have this information, then you must have two other bits of information, and in this case would be the x coordinate, the x component and the y component. So the first thing I would recommend that you would do is always to show the grid. That way it would be easy for you to know what's going on. So here is a grid. And then all you have to do is just click and hold and drag a vector anywhere. It doesn't matter. As soon as you set up the vector to be a certain length, notice here, it's telling you that it has a magnitude of 14.1. That means this is how long the arrow is. And then it has an angle of 45 degrees. Notice that this is 45 degrees from the x-axis. As a matter of fact, if I put it right on the x-axis, you'll see that this is, so it doesn't matter. It's a measurement of angle from any horizontal line, by comparison to the beginning right there. The 10 and 10 here is telling me the following, that in order for you to go from the tail to the tip of the vector, you would have to go 10 units to the right, and that's what the x component is. And you have to go 10 units up, and that's what the second component is. As a matter of fact, you can visualize these, and you see right now, this is what we call the x component, and this is the y component. Of course, as you start moving vectors around, you'll be able to see that you are reducing either the x or the y or whatever the case may be. Of course, if we choose a situation like this, where it looks like a right triangle, that is, an equilateral, a isosceles right triangle, then you get the 45, 45, 90, as you can see right there. Okay, now, what does this x and this y mean in actuality? You really have to think of them as actually what we call a projection of the vector. Imagine there is a light beam shining from above here. This would be the shadow if the light beam is shining in a vertical direction like that. If a light beam is shining from the left horizontally like this would be the shadow of this arrow right here, or of this vector. To see that again in a different style, look at that. You see, this is the idea of, this is really the x component right there and the y component. But traditionally, physicists like to show them, close here, so it would be easy to do right triangle, geometry type of stuff. Of course, if you have a vector that is pointing perfectly horizontally like that, notice how the magnitude is matching with the x, component. If on the other hand you make it perfectly vertical, notice how the magnitude is matching with the y component. And of course, as you can see, the angle is always measured from the x-axis. Now, once you get familiarized and you make sense of this, by the way, this could be an example of, for instance, if I have this situation, imagine, for example, a boat, heading in this direction, northeast. So you could see here that it has an easterly direction motion and a northerly direction motion. So its motion is actually broken down into two parts. So you could see, for example, if this 14.1 is the speed with which it is moving, and since it's moving in the direction of 45 degrees, that's the velocity vector in this case, for example. Then this would be 10 meters per second toward the east and 10 meters per second toward the north. And that's what the meaning also of these x and y components would be. Now, if you happen to add another vector, let's say in the mix here, okay, if you add another vector in the mix and you want to see the combination of these, so imagine, for example, you've got a boat going this way, but then there's a little bit of a, imagine for instance, there would be a little bit of wind or current, a current of some sort heading it this way. So you want to figure out what is the actual heading now of the boat. Well, you would do the sum at that point. Now, of course, having the x and y components of each one of those kind of complicates the thing and makes it look a little bit awkward. So this is why sometimes it may be a good idea to have none of those. But notice now, the boat, instead of going this way, now because of the wind hitting it this way, so now you could see the effect is actually that. The lab 8 that you are going to be doing is basically going to be about what you investigate in situations like these. As a matter of fact, notice here, if I start moving this around, the vector sum, the green one, is going to be changing accordingly, okay, as you can see. Cool. That's it. Thank you very much. And I hope you'll have fun with this.